Balancing chemical equations through algebraic method, part 1. What is the algebraic method of balancing a chemical equation? In this method of balancing chemical equations, we make use of unknown variables as stoichiometric coefficients of the reactants and the products to derive the algebraic equations, and then we solve the equations to get the value of the unknown coefficients in order to balance the equations. What are the different steps required to balance a chemical equation through algebraic method? The various steps involved in balancing a chemical equation through algebraic method can be explained by taking examples. At first, we will solve some equations by taking 3 variables and then with 4 and above unknown variables to understand the method. By taking example of the equation, calcium plus nitrogen gives calcium nitrate. It is an equation with 3 variables. Step 1. Taking variables of the given equation, Ca plus N2 gives Ca3N2. In this step, the variables A, B, C, etc. are attached as prefix or written down for the stoichiometric coefficients of the reactants and the products in the skeleton equation as A, Ca plus B, N2 gives C, Ca3N2, or taking variables of the given equation Ca plus N2, Ca3N2 where A, B, C stoichiometric coefficients are written down below the reactants and the products. Step 2. Deriving the algebraic equations in terms of the variable A we get. In this step, the coefficients of the products are determined in terms of the coefficients of the reactants. The expression for the first reactant or term is always taken as A. So, the coefficients of calcium is taken as A. Since calcium appears in the total equation in 2 terms, it is coming once as 1 atom in the reactant side and it is also present in the product side as one of the product as 3 atoms. So, for calcium, the equation derived will be A is equal to 3C. Similarly, nitrogen N is present in the reactant side as 2 atoms and also present in one of the product as 2 atoms. So, the expression of nitrogen will be 2B is equal to 2C. Step 3. Solving the algebraic equations with respect to A we get. Now from calcium, A is equal to 3C. That means C is equal to 1 by 3A. From nitrogen, 2B is equal to 2C. But C is already 1 by 3A. So, 2B is equal to 2 into 1 by 3A or 2B is 1 by 3A. Step 4. Writing the equation in terms of stoichiometric variables by considering A is equal to 1, B is equal to 1 by 3 and C is equal to also comes as 1 by 3. Step 5. Placing the values of variables as stoichiometric coefficient of the equation. Therefore, the equation Ca plus N2 gives Ca3N2 with stoichiometric coefficients in form of A, B, C becomes 1 Ca plus 1 by 3 N2 gives 1 by 3 Ca3N2. Since we cannot write any stoichiometric coefficients of equation in fractions, thus multiplying the whole equation by 3, we get 3Ca plus N2 gives Ca3N2. Step 6. Writing the balanced equation as 3Ca plus N2 gives Ca3N2. Let us take few more examples of equations with 3 variables. Taking example of the equation hydrogen plus oxygen forms water. Step 1. Taking variables of the equation H2 plus O2 gives H2O as A plus B gives C. Step 2. Deriving the algebraic equation in terms of variable A, we get H is equal to 2A is equal to 2C. O is equal to 2B is equal to C. Step 3. Solving the algebraic equations with respect to A, we get from hydrogen 2A is equal to 2C or C is equal to A. From oxygen 2B is equal to C, but C is also is equal to A, so 2B is equal to A or B is equal to half of A. Step 4. Writing the equation in terms of stoichiometric variables by considering A is equal to 1, then B is equal to half and C also is equal to 1. Placing the values of solved variables as stoichiometric coefficients of equation, we get the equation H2 plus O2 gives H2O in form of ABC as 1H2 plus half O2 gives 1H2O. Step 5. Since we cannot write any stoichiometric coefficients of equation in fractions, thus multiplying the whole equation by 2, we get H2 plus half O2 gives H2O multiplied by 2 is equal to 2H2 plus O2 gives 2H2O. Step 6. Writing the balanced equation as 2H2 plus O2 gives 2H2O. Equation with 3 variables. Taking the example of the equation, phosphorus when reacts with oxygen gives phosphorus pentoxide. Step 1. Taking variables of the given equation, P plus O2 gives P2O5 as A plus B gives C. Step 2. Deriving the algebraic equations in terms of the variable A, we get A is equal to 2C and 2B is equal to 5C. Step 3. Solving the algebraic equation with respect to A, we get from P, A is equal to 2C or C is equal to half of A, O is equal to 2B is equal to 5C, or 2B is equal to 5 1 by 2A, or B is equal to 5 by 4A. Writing the equation in terms of the stoichiometric variables by considering A is equal to 1, then B is equal to 5 by 4 and C is equal to half. Placing the values of the solved variables as stoichiometric coefficients of the equation, we get the equation P plus O2 gives P2O5 in form of ABC as P plus 5 by 4 O2 gives half P2O5. Step 5. Since we cannot write any stoichiometric coefficients of the equation in fractions, thus multiplying the whole equation by 4, we get 4P plus 5O2 gives 2P2O5. Step 6. Writing the balanced equation as 4P plus 5O2 gives 2P2O5. Taking example of the equation, aluminum when reacts with oxygen gives aluminum oxide. Step 1. Taking variables of the equation, Al plus O2 gives Al2O3 as A plus B is equal to C. Deriving the algebraic equations and solving them. Aluminum, A is equal to 2C or C is equal to half of A. From oxygen, 2B is equal to 3C or 2B is equal to 3 into half of A, or B is equal to 3 by 4A. Writing the equation in terms of stoichiometric variables by considering A is equal to 1, then B is equal to 3 by 4 and C is equal to half. Placing the value of solved variables as stoichiometric coefficients of the equation, we get the equation Al plus O2 gives Al2O3 in form of A plus B gives C as Al plus 3 by 4 O2 gives half Al2O3. Step 5. Since we cannot write any stoichiometric coefficients of the equation in fractions, thus multiplying the whole equations by 4, we get 4Al plus 3O2 gives 2Al2O3. Step 6. Writing the balanced equation as 4Al plus 3O2 gives 2Al2O3. Hope you have understood the method of balancing chemical equations through algebraic method by taking up to 3 unknown variables. In the next part, we will discuss about balancing the chemical equations through algebraic method by taking examples of 4 unknown variables. Bye bye for now. Please like, comment and share this video. Subscribe to the channel of Partha World if you haven't till yet. Follow this channel for more interesting videos.